Yesterday we learned about something called the empirical rule, and today we're going to revisit the empirical rule and look at it again. We're going to be talking about probability, but it's really going to be the same thing. Just to refresh your memory, the empirical rule was set up this way. If we have a normal distribution, meaning something that if we have a set of data, it forms this sort of bell curve, then it turns out that if we start with the mean right in the middle of the distribution, then if we mark off one standard deviation, two standard deviations, three standard deviations, and we do that in both directions, it turns out that 68% of the data will fall within one standard deviation of the mean. If you go out two standard deviations in both directions, then you capture 95% of the data. If you go three standard deviations in both directions, then you capture 99.7% of the data. Okay? By doing some subtraction and division, we can figure out that each part of this diagram has these percentages of the data in every zone. And the easiest thing to do is just to memorize all of these numbers. Basically memorize this entire chart. The 68, 95, 99.7, that's the empirical rule. But I also want you to memorize the 34%, the 13.5, the 2.35, and the 0.15%. It will just make your life a lot easier. Okay? Alright, what percentage of the area under the curve is shaded? Well, on this one, the entire thing is shaded. So that is obviously 100% of the data. Look, real quick, you know, here in the middle we have the mean. Now, when we looked at the, when we learned about the empirical rule before, I wrote it like this. So there is the mean. First of all, I use this letter mu to represent the mean. Look, for now, just to understand, there are two different symbols that we use for the mean. This mu and the x bar. There are samples, and then there are populations. A sample is a part of the whole population. So we are supposed to use x bar when we are talking about a sample, and we're supposed to use mu when we're talking about a whole population, but I really don't want you to worry about that right now. We'll get into that in future lessons. For now, just understand that sometimes you will see this symbol for the mean, and this mu, and sometimes you will see x bar. Anyway, remember how I put plus one standard deviation, two standard deviations, three standard deviations. Same thing on the left side. Please understand that this is the same thing. But instead of just putting plus one standard deviation, two standard deviation, three standard deviations, they're mentioning from the mean. They're saying we're taking the mean plus one standard deviation, the mean plus two standard deviations, the mean plus three standard deviations. So, you know, but that's what I was suggesting with what I wrote anyway. I just didn't write the mean part over and over again. So do not look at this and think, well, what's this new crazy thing? It's the same as what we did before. One standard deviation, two standard deviation, three standard deviation. Okay, what percentage of this area under the curve is shaded? Well, you hopefully memorized these figures. This is 34%, this is 13.5%, this is 0.35%, and this is 0.15%. Same thing on the left. 34, 13.5, 2.35, 0.15. So as far as what is shaded, what we have is these are shaded, and these are shaded, and these are shaded. Okay? you could look at it this way. Everything is shaded except for the two 13.5s. So probably the quickest thing to do is to start with 100% and then subtract the two 13.5s. And whatever's left over, that'll be everything that's shaded. Or you could sit there and add. If I add these two, that's going to make 2.5. If I add these two, that's going to make 2.5. If I add these two, that's 68%. So I could do 68 plus 2.5 plus 2.5. All right, either way I should get the same answer. Either way, I am getting 73% of the data is shaded. All right, what percentage of the curve is shaded in this picture? All right, hopefully you can see that we're just dealing with this part of the picture right here. This is the only part that's shaded. Alright, well, you should be able to know this one automatically without even dealing with the numbers inside, without even dealing with the 34s and the 13.5s. Alright, if you know these numbers, you could certainly add up those numbers. But if you remember the basic information that we learned right at the beginning, these are the three key numbers. The 68, the 95, and the 99.7%. Remember, the 68%, that is one standard deviation in both directions. If we go 2 standard deviations in both directions, that's your 95%. And if you go 3 standard deviations in both directions from the mean, that's going to be your 99.7%. In this case, here's my mean right here. So this is 1, 2 standard deviations. 1, 2 standard deviations. Okay? So 2 standard deviations from the mean, that's always going to be 95% of the data. Alright? And sure enough, if you add these numbers up, you're going to get 95%. Okay. So many ways to do it. What percent of the data is this? Again, we don't need to add the 34 and the 13.5 and the 2.35 or the 0.15. We don't need to add these numbers up. We could if we remembered them, but it would be much more simple to understand what percent is the entire picture. Alright, the whole graph is 100%. So here we have shaded exactly half of this picture. Alright, if half the picture is shaded, then that is 50%. That's 50% of the data. Alright, let's look at number 5. Alright, this one, our best bet may be just to simply add. We've got this piece down here is a 0.15%. This 2.35 is not shaded. Here we have a 13.5. Here we have a 34. And here is a 13.5. And over here is another 0.15. Okay, so it'd probably be as easy as anything else just to add up these numbers and see what you get. Alright, if you add up all these shaded areas, you're going to come up with 61.3%. Don't forget the percent symbol. So that's number 5. It's also valid to subtract if you want to. It's actually slightly faster if you subtract instead. So let me just show you. Because there are fewer shaded areas, so it would be slightly faster to start with 100% and subtract the 3 unshaded areas. So I could subtract this 2.35, subtract this 34, and subtract this 2.35. So if I do 100 minus 2.35 minus 2.35 minus 34. Okay, once again, you're going to get 61.3%. Either way. Okay. Look, after a while, you guys are going to begin to memorize that, yes, we memorized that this is 2.35%. And we also memorized that this is 0.15%. But these two occur next to each other often enough that you're going to accidentally memorize that together this is 2.5%. Alright, same deal over here. Alright, so this is also 2.5%. Okay, so the shaded area is really 2.5 plus 2.5. Alright, if you put that together, that is 5%. Okay, that is the answer. Another way to look at it. Alright, there are lots of different ways to look at it, and I really want you to understand them all. Okay, here's the mean right here. So from here to here, this is 2 standard deviations in both directions. Alright, minus 2 standard deviations, positive 2 standard deviations. Like we talked about a second ago, alright, 2 standard deviations in both directions. Alright, that's going to be our 95%. Like from here to here is our 95%. Okay? So that means this white area here is 95%. Okay? So since the whole thing is 100%, that means the remaining shaded area has to be the extra 5%. So either way, you're going to get 5%. Alright, moving on. Now, a normal distribution has a mean of 253 and a standard deviation of 18. Find the probability that a randomly selected x value from the distribution is in the given interval. Draw a picture. Okay, I think we need to put these numbers in the picture. So the mean is 253, so it goes right in the middle. The standard deviation is 18, so that means I can add 18 to the mean and get the next number and the next number and the next number. So that will give me 271, 289, and 307. Okay, and of course, again, I got that by adding 18 over and over again. Alright, because that is the standard deviation. Alright, now let me just erase that for a second. Okay. Now, if I want to go in the opposite direction to the left, these numbers should be getting less and less, but again, it's the standard deviation. So I will subtract 18 a couple of times. So that'll give me 235, 217, and 199. Okay, do not forget these numbers that we are supposed to memorize. They will come in very handy. So look at number 7. Now, do not get spooked by this word probability. Wait a minute, we hadn't talked about probability before. We were just talking about percent, and that's it. This is just another way of saying the same thing, okay? If I randomly pick 100 of anything, the probability that I'm going to pick numbers in a certain zone, a certain interval, is the same thing as these areas under this curve. So this is just the same thing as we've been doing, so don't get thrown by the word probability. So between 217 and 271, so here's 217, and here's 271. Okay, so the probability of randomly selecting a value from this region is just going to be what we get if we add up these three numbers. Okay, so just add them up and then you'll know. And that is 81.5%. So that'll be the answer number 7. Let me mention one more thing. The zone from 217 to 271, that can be written in interval notation this way. An interval is just a zone, for beginning and ending. So in this case, beginning with 217 and ending with 271. So instead of writing it this way, I could have written the problem this way, and it would mean the same thing. Okay, so that's number 7. Number 8, between 253, which is here, and 307, which is here. Okay, but between these numbers, all right, this interval goes from here to here. So I have a choice. I could add 34 plus 13.5 plus 2.35. I could add up those numbers. Okay, and I am getting 49.85. Okay, 49.85%. That's the answer. Okay, but also I could have thought of it this way. This region is almost half of the data. Okay, it's half of the data except for this one little piece on the end. Alright, so it's the right hand side except for the last 0.15%. So I could have started from 50% and just subtracted 0.15%. Alright, either way that's going to give me my 49.85%. Okay, just multiple ways of thinking about it. Alright, let's look at number 9. Alright, what about between 289 and 199? So here's 289 and here is 199. So this is the interval that we are speaking about. Okay, so I could just add these 5 numbers up. So if I do that, alright, if I add up all those numbers, what I get is 97.35%. Alright, please do not forget the percent symbol. Alright, or I could subtract. Or this zone, this interval, is the whole picture except for these 3 zones. So I could start with 100% and subtract. I could subtract 2.35 and 0.15 and another 0.15. And it better give me the same answer again. 97.35%. Alright, so you can either add what you have or you could subtract what you don't have. You should get the same answer either way. Don't forget this could have been written in interval notation as 289. Whoops. Should have been a 9. 289, comma 199, and that would have meant the same thing. Number 10. Okay, between 253 and 271. So here's 253 and here is 271. Well, that is obvious. Alright, there's only one zone, so it's going to be 34%. Okay, between there and there. Alright, too easy. Alright, new problem. A normal distribution has a mean of x and a standard deviation of sigma. Find the indicated probability for a randomly selected value, x value from the distribution. Draw a picture. So look, they didn't give us any specific numbers. They just gave us, x bar and sigma. So we will draw the picture like we always do. But instead of filling in actual numbers, we will just put, basically the original, what we had from the notes. There's the mean right in the middle, and then positive 1, 2, 3 standard deviations, negative 1, 2, 3 standard deviations. So it's just a matter of understanding what this means over here. First of all, the p. Please understand that if you have a p and then parentheses and you put something inside, like if I have a p in parentheses and I write rain inside, that means the probability that it's going to rain. Okay? If I wanted to talk about the probability that you are going to pass this class, I would put a p and then inside I would put you pass. Okay? And that would mean the probability of you passing. Okay, so let's just get that under our belts, into our bellies. So when you see this p and whatever this is, it's saying what is the probability of whatever this is. Okay, look at this symbol right here. You see it's an inequality. Is this a less than symbol or a greater than symbol? Does this x is less than or equal to, or x is greater than or equal to? I'm hoping you automatically know that this is saying less than or equal to. So this is saying what's the probability of randomly picking an x value that is less than or equal to the mean plus 2 standard deviations. Again, look, focus on this part. Plus 2 standard deviations. Okay, when you see that plus 2 standard deviations, they're talking about this spot on the graph right here. Alright, they're saying the mean, they're saying counting from the mean, and then 1, 2 standard deviations. They're simply referring to this point on the graph. Now, when we talk about picking a value less than this, is that going to be left or right of this mark? Well, yeah, less than is always going to be to the left. So this is saying, really, what's the probability of picking an x value randomly to the left of the 2 standard deviation mark? That's what this is all really saying. So, switching to highlighter mode, alright, we're being asked what's the probability, if we just randomly pick, what's the probability of randomly picking a value that is in this region? Okay, so I have lots of different choices in terms of how I want to calculate this. The long way would be to sit here and add up all of these numbers. 1, 2, 3, 4, 5, 6 numbers. I could add all these up, and that would give me the answer yes. Another way to think about it is I could start from 100%. Alright, that would be the whole thing, and just subtract these two guys. Alright, that's the only unshaded part. So I could subtract 2.35 and I could subtract 0.15. Okay? If you want to do it in your head, you would go ahead and recognize what percentage are these two numbers put together. Alright, you're going to see it enough times that you might as well just memorize it. This is 2.5%. If you add these two up, it's 2.5%. So if you take 100 and subtract 2.5%, that should be what you have over here. Okay, so what is that answer? Say it out loud. Alright, that is 97.5%. Alright, so that is the answer. 97.5%. That's the answer. One more way that you could do it is if you look at this zone from here to here, plus or minus 2 standard deviations. Alright? We learned that if we're talking about 2 standard deviations in both directions, that's 95% of the data. Okay, so that tells us that from here to here, I guess I shouldn't have this number right here looking like it's the answer to that question. Okay, from -2 to +2 standard deviations, this is 95% of the data. So then we could just go ahead and take this extra part right here. These two are always 2.5%. So I could immediately glance at this and go, okay, well that's 95% plus 2.5%. So that together, that's going to equal 97.5%. Why does my ink vanish a little bit? I don't know. Alright, so there's lots of different ways to think. I can add, I can subtract, I can do the 95% and add the other part. Anyway, let's look at another example. Hopefully you're sort of getting ahead of me as I'm doing these, and you're just using me to check your answer. If you're just watching me and just copying whatever I do, you're not going to really learn. So as soon as you understand, I want you, especially since I'm not really there, to look you in the eye and you interact with you. Certainly, if you once you feel like you understand, work ahead, get ahead of me, and just use my voice and pictures to check your answers. All right, so this is asking what's the probability of randomly picking a value, okay, that is greater than or equal to. So this is greater. Greater means to the right. All right, to the right of what? Focus on this. -3 standard deviations. Okay, it's the mean minus 3 standard deviations. But that just means starting from the mean, go 3 standard deviations over. Okay, so in other words, this is the spot that we are talking about right here. And we want to be greater than or equal to that. So we are talking about this. To the right. Like this. Okay, we are talking about this zone. So the question is, what percent am I shading here? What percent are we talking about? Because that percent is the same thing as the probability. Well, definitely the quickest thing to do for this one is to recognize that this is almost 100% of the graph. Almost. Except for this wee little bit on the end. So the quickest thing to do would be to start from your 100% and subtract 0.15. Okay, so I'm pretty sure that's going to be 99.85%. Alright, that is what my gut tells me. It definitely would be the long way to add up all these numbers from here to here. But that would work. That would work too. Alright, number 13. Focus on the +2 standard deviations. Okay, that lets us know that we are talking about this spot right here. Okay, that's your +2 standard deviations. This is a greater than or equal to symbol, which again means we are looking to the right. So this question is asking what's the probability of randomly picking a value in this area. we've memorized this probably by now, that this plus this is 2.5%. So that is the answer to number 13, 2.5%. Okay, what else? All right, look at number 14. Focus on this, -1 standard deviation. That is 1 standard deviation to the left. So we should be looking at this spot right here. This is a less than or equal to sign, which means we should be looking to the left of this -1 standard deviation. So we're talking about this area right here to the left, like this. Okay. So just add them up. It's probably the easiest thing to do. This and this, that's 2.5. So 2.5 plus 13.5. Okay, that is 16%. So that is what we've got for number 14, 16%. Alright, look at number 15. Focus on the positive 3 standard deviations. That means we're looking at this spot right here, 3 standard deviations to the right of the mean. This is a less than or equal to symbol, which means we are looking to the left. Okay, to the left of here. So that's going to be like this, alright, to the left. Alright, it's a big area. So we're talking about everything over here. So what percentage of the graph is shaded now? Because that will be the same as the probability. We did one just like this a second ago. This is everything except for this little bit on the end. So the quickest thing to do is to do 100% minus your 0.15%. Alright, which again is going to leave 99.85%. So that is number 15. Number 16. Focus on your positive 3 standard deviations. That means we're talking about this spot right here on the graph. Alright, this is a greater than symbol, greater than or equal to. So that means we should be looking to the right. Alright, to the right of our 3 standard deviation mark. Well, that is just this little bit right here, teeny tiny. There's nothing to add, that's it. That's going to be your answer right there. Alright, the probability of getting a value in this area is 0.15%. It's less than 1%, much less than 1%. Alright, please do not forget the percent symbol. What's all this then? Alright, nothing. That was it. That is the end of the lesson. Alright, there will be a separate video for the homework, but you can watch that later. I hope that you understood. You can watch this video again if you need to. I'll see you later. Wake up!